Hello everyone. Today we're going to talk about density. Density is a word that should be familiar to a lot of people, right? It's something that you've seen in science classes in the past. It's something that is used outside of science when we talk about things like population density. But today we're going to focus more on the scientific and mathematical parts of density. And when we talk about density, we're talking about how much of something is able to fit into a certain space, right? It's an amount per space type of measurement. Going back to population density, which I just said before, it's about how many people live in a certain area, right? So cities have a very high population density, right? A lot of people in a small area, whereas more rural and like farm towns have low population density. There's not a lot of people and a lot of open space. When we're talking about density in chemistry, we're talking about how much mass is packed into a certain volume, right? Which is the same as you may have talked about it in earth science or living environment, right? Scientific density is pretty much the same thing, right? How much of something is stuffed into a certain volume. Right? Things with high density, right? Something like steel has a lot of matter packed into a small amount of space. Whereas something with a low density, like cork or styrofoam, would have a low amount of matter packed into a amount of space. Right? If we're going to compare the two and we have two perfectly square, equal boxes, right? Something with a high density has much more filling in it, right? Much more stuff packed into it, whereas something with a low density has a lot less stuff packed into it. And this directly affects the weight of those things, right? This comes into play with movie props where you see something that you know should be heavy, but in fact it just looks heavy and it's actually made out of something like styrofoam or something like cork, where it's very easy to lift up, even though you know, based on your experiences, that it should be heavy. Mathematically and chemically, when we look at density, we have a formula for finding it. And density is going to be equal to the mass of the thing over the volume of the thing. Alright, so density equals mass over volume. This formula is on table T of the reference table for you always to have, and it will tell you that D equals density, M equals mass, and V equals volume. So that's there for you to refer back to and use for all time. An important and interesting thing about density is that as long as you have the same substance, the density should remain the same. It doesn't matter how much or how little of that substance you have. If it is the same substance, it should have the same density, the same ratio of mass to volume. Right? So the example I used here is a paperclip made of steel is going to have the same density as the steel I-beams that you see used to build bridges and construction and such. Right? Right? Even though they weigh very different amounts, even though they have very different volumes, that ratio of mass over volume should be the same if they are both made of steel. Right? Now, if it changes and we say this is a gold paperclip and a steel girder, they're obviously not going to have the same density, right? The substance needs to be the same. Right. And so we're going to do some practice. Right. Which one is more dense, a pound of rocks or a pound of feathers? Right. This is not a trick question. Take somewhere between 5 and 10 seconds, and then we will talk about our answer. right, so here, even though they weigh the same amount, right, they are both 1 pound, that does not impact density, right? Density talks about which one has the same mass in a smaller volume. And so if you have a pound of rocks and a pound of feathers, which one is going to take up less space? And that's going to be the rocks, right? You're going to be able to fit a pound of rocks in a small bag, whereas a pound of feathers, you're going to have a lot more space to have a pound of feathers. Right, because they're the same mass, you want to find which one has the smaller volume to have a bigger density. We're not always going to have multiple choice questions, right? Sometimes questions get asked in a long answer form. So here we have two different long answer questions. I'm going to give you some time, right? Let's say 10 to 15 seconds. Pause the video, please, if you need more time. And then we will go over some of our answers here. And remember that density is equal to mass divided by volume. Right? And it kind of, if you look at it, looks like a heart. Right? So density, we love density. Alright, so 10, 15 seconds here. Pause the video if you need more time, which I anticipate you will. But I'm not just going to leave dead air. That's bad radio. Alright, so for the first one, we have two numbers here, right? 10.3 centimeters cubed and 89.6. We know that density is going to be equal to mass over volume. It's important that we're able to identify which of these numbers is which. Right? They tell us straight up has a mass of 89.6 grams, so that means that that's going to be our numerator. Centimeters cubed is a example of a volume measurement, right? Cubic centimeters is something that we're going to use, right? 3 dimensions, length, width, height, to determine the volume of a substance. That means 10.0 centimeters cubed is going to be our numerator. And when we go ahead and solve this out, we're going to take 89.6 divided by 10, which is going to give us 8.96. And something interesting happens with the units here, and that's they stay. Grams and centimeters cubed don't cancel each other out. And so what we end up with is a unit that shows both of these units combined, right? 8.96 grams per centimeter cubed. Right? This joint unit here is the same as saying like miles per hour, pounds per square inch. Right? It's a combined unit that, because we're talking about a ratio, we're talking about the mass to volume ratio. And this number, our density number, is going to represent that mass to volume ratio. Right? For our second problem, I'm going to change font. Let's go with blue. We have 3 different length measurements, and it says the mass of this object is 94 grams. So here, again, we're going to do mass over volume. We know mass is 94, but we have to actually find our volume, right? Length times width times height is going to give us 12 centimeters cubed. And when we take that and do our division, and we say 94 divided by 12, we're going to end up with 7.83 repeating. We're just going to stop at 7.83 grams per centimeter cubed. You can, if you would like, put the repeating sign over it, but that's not usually something we do in chemistry. It's not wrong, but it's not something you normally see. And as far as rounding goes, notice how we kept the hundredths place in both of these. Normally, if you have a number that goes nicely to the hundredths or the thousandths, that's the place you want to round, right? I wouldn't want to see somebody put this number as their density measurement, right? Even mostly because that 3 is disgusting, but all right, you want to keep it to the hundredths or the thousandths place when you're giving a number answer. And we press forward. Again, we've got 3 more density practice problems. And so I'm going to give you some time, pause the video, work on them, set them up, and then we will walk them through. All right, so again, we want to remember that density equals mass over volume. We're looking here at another thing that has given us 2 numbers. Right? The first number, we're talking about pouring something into a graduated cylinder. We get the clue of milliliters. This is a unit of volume, so that means this measurement is a volume measurement. The mercury used to fill the cylinder weighs 306.0 grams. Giving us the clue that this 306.0 is our mass volume. And so for our density, we would take 306.0 over 22.5. Which is going to give us a value of 13.6. And now again, remember our units aren't canceling out, so we're going to get grams per milliliter as our density. For our second, again we are given a volume and we're told the mass, right? So we've got volume and mass. And so when we go and plug in, we're going to take 65.14 over 35.4. And when we plug that in, we're going to get 1.84 grams per milliliter. Right? Again, our units are not canceling here, so we should have both of them present. Right. For this last one, we are given a mass and also given a density. Right, so this problem is set up a little bit different, right? Here we were given a mass and we were told a density. So here when we're setting up, we're not looking for density. We have density. We know density is 10.5 grams per milliliter. We know our mass, which is 2,500. And we're trying to solve for our volume. So here we're going to actually cross multiply. Right, 10.5 grams per milliliter times x equals 2,500 grams. Divide both sides by our 10.5 grams per milliliter. And end up with 238.0 0.1 when we do our rounding. And here, when we have, I'm going to do this up top here, when we have grams divided by grams per milliliter, grams are actually going to cancel out. We can treat this like dividing something by a fraction. So we're going to keep, multiply, flip. And if we want to solve this out, right, we have grams on top, grams on bottom. Those are going to cancel out. We're going to be left with milliliters over 1, which is the same as milliliters. And that will be our unit at the end, which makes sense. They asked us for a volume, so we want to give them a volume as our answer. Here, which one is it more dense, a steel paperclip or a steel girder? And here this is a trick question, right? Even though one is much bigger than the other, they do both have equal densities. They are both steel. And so if they are both steel, they're going to have the same densities. It doesn't matter if this is a steel paperclip or a steel hammer or a steel screwdriver. I'm running out of things that I know that are made of steel. Right? It doesn't matter what the two things are. If they're both steel, it doesn't matter what shape we've put them in or how much of it there is, they will have the same density. I've got one more set of practice problems here. Again, pause the video, give them a shot. I'm going to wait a little bit of time and then go over them. All right, so for the first one, again, we are given mass and volume, and we need to solve, right? Grams is a measurement of mass. They tell us it has a mass of 12.5. Centimeters cubed is a measure of volume, so they give us our volume as well. We want to put 12.5 grams over 13.0 centimeters cubed to give us a number of grams per centimeters cubed, which will end up being 0.96. For our density here. For our second, we are again given a length, a width, and a height, right, which we're going to use to find volume. And we're given a mass of 86. And so when we plug in, we're going to take 86 grams divided by 2 times 3 times 4, which is 24 centimeters cubed. And that's going to give us a density of 3.583 grams per centimeter cubed as our density value. And so we're going to stop there for today and transition ourselves back to the Google Meet, where I have a couple of announcements, and we're going to take attendance. So I will see you there.